Okay, now for linear motion, we have graphs. We call it linear motion graph. Okay, this is the one. Yeah, linear motion graphs. Okay, linear motion graphs. So we have three types of graph. We have a displacement time graph, and then we have velocity time graph, and then we also have a acceleration time graph. Okay, now let's look at displacement time graph. Yeah, displacement time graph, which is a ST graph. Okay, the thing important about this displacement graph is talk more to position. Okay, displacement graph shows more about the position of the object. Okay, displacement time graph. So what is mean by this displacement time graph? So first of all, what is it mean by the x-axis, the time axis over here? The important key about displacement graph is, okay, here this is displacement 0 meter. Okay, so the time axis over here, actually it means origin. It means origin. That means if the graph goes up, that means it's going away from origin. So this one also, it has a positive displacement and also negative displacement. Okay, we can say the positive displacement is at the right hand side of or above the origin. Okay, for example, I make a line. Yeah, maybe I make a line here. Okay, this is the origin at the middle. Okay, at the middle. So if the object is over here at the right hand side, then this one is positive displacement at the right hand side. But yeah, the middle, this one is the origin. Okay, the middle one is the origin. Okay. So, but if the object is at the left hand side, means the position is negative displacement. Okay, so positive displacement means the object is at the right hand side of origin or above the origin, but negative displacement means the object is at the left hand side or below the origin. So if you look back to this, okay, just this one, I just want to transfer to other place. Okay, maybe over here, yeah, for the meantime. Okay, so let's look at this. So the graph like this one, the graph here, the graph is on top of the origin. That means the object is at the, like this one, at the right hand side of the origin. But if the graph, let's say the graph goes back down, this one, if the graph like this go back down to origin, that means it go back to origin. It go back to origin. That means the car, like this one, the car goes back to origin. Goes back to the origin. If the car goes back to origin, that means the graph will come back to the origin. But if the graph, let's say, continue further down, means this one, the car has moved to the left of origin. That means the car now has moved to the left of origin. Okay, this is what it means. Yeah, so that's why this is a position graph. Okay, so the graph above this one is, that means the object is at the right hand side. The object is at the right side of origin. But if negative displacement means at the left hand side of origin, the center is the origin. Okay, I hope you understand, yeah, the concept. If the graph comes back to the time axis, means the object will return to origin. Okay. Okay, now how about the gradient of the graph? The gradient of the displacement time graph is actually velocity. The gradient of displacement time graph is velocity, because v is ds over dt. ds dt means gradient. Yeah, gradient of displacement time graph. Yeah, that's velocity. Now, talking about velocity time graph. Velocity time graph is talking about the velocity of the object. Velocity of the object. So, first of all, what does it mean by the time axis over here? What does it mean by the time axis over here? The time axis over here means the object is not moving. Yeah. This one is the zero here. It means it is not moving. The object is not moving when over here. So let's say so start from here. If you look at this graph, the graph start from zero. The graph start from zero. That means the object start from rest, or the car start from rest, and then it goes up. The velocity goes up, become faster and faster. If the graph did come back, if the graph come back to the time axis, what does it mean when it touches the time axis? It touches the time axis. It means what? It means the car come to a stop. The car come to a stop. Yeah, after some time. So like over here, let's say the car comes back to here. That means the car. This one is the car going faster and faster, and going faster and faster, and then car now the car accelerate, become faster and faster until you know, maybe the velocity become 10 meter per second here at the top speed, and then here is slow down, and then the car stop again. Yeah, here the car stop again. Okay. But if the graph goes back, go down, that means it moved to the other direction. It moved to the other direction. Okay. It moved to the left. So you must also understand what does it mean by positive velocity. Positive velocity means the object is moving to the right. Is moving or moving upwards. The direction of the motion is moving to the right or upwards. If negative velocity means the object is moving to the left or downwards. Okay. So what I can say is the object here it start from rest, then as the velocity increase, and then here at the top speed, and then here velocity decrease, and then come to a stop, and then velocity increase again, but it's moving in the opposite direction. Okay, this is what it means. So two different meaning for the time axis for both displacement graph and velocity graph. Displacement graph, it is the origin. The time axis means the origin, zero displacement. If the graph comes back means that means the object comes back to origin. But if the graph of velocity, when it comes back to the time axis, means the car stop. It doesn't come back to origin. Don't say that the car come back to origin. Yeah, for velocity graph. The displacement graph, if the graph comes back to the time axis, means it come back to origin. But for the velocity graph, if the graph comes back to the time axis, it doesn't mean that it comes back to origin. It's not. When the graph is over here, it does not mean that the car is already at the origin. No, the car actually means it stopped. It stopped over here. So maybe I visualize this out. Okay, about this graph. Okay, you look at this one. Yeah. Here all is positive velocity. Positive velocity means the car is moving to the right, faster and faster. It's moving to the right, and then when graph goes down, this one means it's going faster and faster, and then graph. Okay, the first part. Okay, the car is going to the right. Okay, velocity positive. Maybe it start from zero velocity and start from rest, and then it achieve very high speed, which is maybe equal to 10 meter per second. Understand? It is over here. But then yeah, that means from here to here. Maybe I can draw a little bit nicer. become faster and faster. It become faster and faster, you know, until it reached the 10 meter per second. But then the object after that is slow down, you know. So just now for it become faster and faster, it accelerate. But then after that it slow down. Yeah, this is the velocity graph. I hope you understand. Yeah, it slow down. It slow down. That means now the car becomes slower and slower. You know, becomes slower and slower. Becomes slower and slower. Until it finally stop. Maybe here, over here, this is origin. Yeah, here is origin. It starts from rest, going faster and faster, and here is the fastest, 10 meter per second, and then it slow down, and become here. Over here, velocity. Now velocity is stop. Velocity becomes 0. So this is what it means by stop. Yeah. Here it start from rest, and then here it stop. Yeah, velocity 0 over here. You see that? This is what it means by the graph comes back to origin. Yeah. It start from 0. That means start from rest, and then it will become faster and faster. And then it slow down. And then come to a stop. It come to a stop. Velocity 0 over here. So, is it mean that the object already go back to origin? When the graph comes back to the time axis, is it mean that the object already go back to origin? No, it just means it stop. So, it has a different meaning compared to this graph, understand? Different meaning, this graph looks the same, but it does not mean the same as the displacement graph. This displacement graph means position, it comes back to origin. But this one, when the graph comes to the time axis, it means the car stop. The car is stopped, but the car is already far away from origin. This is the thing you must know. Okay, but when the graph goes even down, means now the velocity is negative. Yeah, if below graph the velocity is negative. Velocity negative means what? Velocity negative means the object now is moving to the left or downwards. That means now object is moving down to the left. Already. Now it's going back to origin. And then it becomes faster and faster, more and more negative. Do you see that? The graph actually velocity increases, but velocity increases in negative direction. That means the car becomes faster and faster already. But moving in the opposite direction. So what I can say is if the graph is above the time axis, yeah, means about this part. Okay, what I can say about this part, all right, this part is this part. That means velocity is moving to the right. Yeah, velocity positive. Yeah, bear in mind this is velocity positive. That means its velocity is positive. All of this, you know. Just want to write it so clearly for you. Yeah, and that means the object is moving to the right. But for the graph below over here, velocity is negative. Velocity is negative means it's this part. That means the car is actually moving to the left already. Starting from here, the car is actually moving to the left because velocity negative. The car is moving to the left. So velocity is for this part, velocity is negative because the car is moving to the left. Understand? So velocity negative means the object is moving to the left or downward. Okay. All right. That's I think I explained quite clearly over here. Now, looking back to this graph. So talking about the acceleration of the talking about the gradient of velocity time graph. Gradient of velocity time graph, the gradient is actually acceleration. Acceleration is dv over dt. Just like velocity is the gradient of displacement graph. Yeah, ds dt is velocity. So velocity time graph, the gradient is the dv dt is acceleration. Okay, acceleration. So look at here. The gradient of displacement graph is velocity, but the gradient of velocity graph is acceleration. That's it. Okay. And then another thing for velocity graph, one special thing about is area. We talk about area under velocity graph. We don't talk about area under displacement graph. Area under displacement graph has no meaning. Okay, area, but area below the velocity graph, is displacement. Displacement. So displacement means how far it moves. Like you see how far if the graph the area is above the time axis, means how far the object move to the right. But area below the time axis means how far the object move to the left. That's what it means. Yeah. If you look to my another concept videos, explain more clearly about the area under the graph. Okay, about the animation one. Yeah, I hope you looked into that that videos. Okay, now let's talk about this. This positive and negative sign is so important. Okay, yeah. Just now, gradient of displacement is velocity. Gradient of velocity is acceleration. So area of velocity is displacement. This is very important. Yeah. Now, this one also, you must understand what's the meaning when positive displacement and negative, positive and negative for displacement, velocity, and acceleration. I hope you get this correct. Okay. Positive displacement means it's more to position. Yeah, when talking about displacement, it's more to position. Position. Okay. So displacement positive. Maybe I should put this one. This is the one I should write. Yeah. Cut. Paste it over here. Yeah, over here. See that? This displacement is more to position. So if we have a positive displacement, positive position means the object, this is the object, is at the right hand side of the origin. This is the origin. If positive displacement means the object is at the right hand side of the origin. Negative displacement or negative position means the object is at the left hand side of the origin. Okay, so it's more to the position. All right, more to position. So you cannot say let's say I give one example like this. I give one example. Yeah. Okay, maybe this is the origin. Let's say now I have a car. Going to the right, and then it returns to here. Go to the opposite. It move to the right and then move to the left. So what's the displacement? At this position? Is it positive or negative? Is it mean that the object already moved to the left? Means it has negative displacement? No. Yeah. About the motion moving to the right and moving to the left, that's more to velocity, the direction of the motion. This one, when talk about the motion, that we use velocity. Velocity, if with velocity moving to the right or upwards, is positive. Like this one, if the object moving to the right is positive velocity. But if the object is moving to the left or downward, like this one, object moving to the left, is negative velocity. This one has negative velocity. You understand? Positive velocity and negative velocity. So velocity is more to the direction of the motion. But after the whole process, object move to the right and move to the left. After the whole process, what's the displacement of the object from the origin? Because what's the displacement? Displacement is the shortest distance between the initial and final point. Okay? So what's the displacement of this object? The displacement is still positive because the object is still at the right hand side of the origin. You understand? I hope that after this class you understand already. Okay, so even though the object has moved to the left, but finally when talking about displacement of the object at this position, the displacement is positive. The displacement is positive because it is at the right hand side of the origin. Okay, but velocity, initially it has positive velocity, and then after that it has negative velocity. So velocity is more to the direction of the motion. Direction of the motion. Yeah, this velocity is more to direction of the motion. Displacement is more to position. And then acceleration is more to the resultant force. It's more to resultant force. If acceleration, more refer to resultant force. Why we refer acceleration to resultant force? Because of the formula. Total F equal to ma. So the direction of the acceleration always follow direction of the resultant force. If the resultant force is to the right, so acceleration also to the right. If resultant force to the left, acceleration also to the left. So acceleration always follow the direction of resultant force. So acceleration, when positive acceleration means the resultant force is actually to the right or upwards. If acceleration negative means the resultant force is to the left or downwards. Okay, it follows direction of resultant force. Now, talking about acceleration versus velocity versus acceleration, whether the object accelerate or decelerate, this is a very interesting things to discuss. I cannot discuss in merely one table. I need to give you example. Then you can see what really make the object accelerate and decelerate. Okay, as you can see over here, many students have misconception about this. Many students have misconception says that acceleration positive means the object must accelerate. Acceleration negative means the object is decelerate. Is this correct? Is this correct? In some case, yes. In some case, not. So this is wrong. I can say this is wrong. This is only true. This case is only true if the velocity is positive. But if the velocity is negative, this one become opposite. Okay, so this is actually a misconception. Now I would like to say that this is a misconception. Okay, blankly I say this is a misconception. Acceleration positive means accelerate. Acceleration negative means decelerate. It's a misconception. The right way to think about acceleration is this one. Acceleration positive, what does it mean? Acceleration positive means resultant force is to the right or upwards. Acceleration negative means the resultant force is to the left or downwards. Okay, because it follow the resultant force, total F. Total F equal to ma. Okay, now talking about whether the object accelerate or decelerate, we need to do comparison between velocity and acceleration. That's why I say velocity versus acceleration. So if the object accelerate, okay, let me tell you how will the object accelerate. I have a car. Now, let's say the car is moving to the right, so velocity is positive, yeah, because we know that velocity positive means the object is moving to the right. But how will we make this object accelerate? Means we want to make the velocity faster and faster. We want to make the velocity increase and increase. Make the object make the car moving faster and faster to the right. How? The acceleration need to be in same direction. You understand? The acceleration need to be in the same direction. That means the acceleration need to be positive also. Need to be in same direction. If velocity and acceleration in same direction, both to the right, that means I press the oil. I press the oil, then the resultant force. Then let's say we ignore about the friction. Okay, let's say the driving force, the thrust force. The thrust force is moving forward. The thrust force is moving forward. So this one causes the acceleration F equal to ma. Yeah. Let's say the total force is only the thrust force. Yeah. After minus the friction. Yeah. Okay. Total F equal to ma. So acceleration follow the thrust force. So acceleration is in the same direction with the velocity. So when acceleration and velocity have the same direction, this object accelerate. What does it mean by accelerate? Accelerate means velocity will become faster and faster. That means velocity will pick up maybe from rest, from 0, then become 2, then become 4, then become 10, and faster, moving faster and faster. Understand or not? Let's say now, if this car release the oil, no more pressing against the pedal. Maybe he brake. Let's say he brake. If he brake, then what happened to the resultant force? What happened to the resultant force? Now the force is only the friction. The friction is moving to the left, isn't it? F equal to ma, friction. Okay. But the car is moving to the car is still moving to the right. Car velocity positive. But now the friction is to the left, the force is to the left, so the acceleration is in the opposite direction. Acceleration is in the opposite direction, A negative. Okay, why acceleration to the left? Because the acceleration need to follow the force, isn't it? The force to the left, the acceleration must to the left. Okay, in this case, you see, acceleration and velocity, they are in the opposite direction. They are opposite direction. So what happened when acceleration and velocity in the opposite direction? Decelerate. Becomes slower and slower. That means velocity become slower and slower. So that means moving very fast becomes slower and slower until finally it comes stop. Understand? So what I can say is, if velocity and acceleration same direction, they accelerate. But when velocity and acceleration opposite direction, it decelerate. Okay, it may seem that you might think that accelerate when A positive means accelerate lah. You may think like that. Okay, when acceleration negative means it decelerate lah. So it seems that this is not a misconception for you. Okay, now let me give you another example. Let me challenge you another example. What if right now the car is moving to the left? Now what if the car is moving to the left? Velocity negative. Velocity negative. So now, okay, now how to make this car accelerate? How to make this car accelerate? Of course, now the car is moving to the left, so I press the oil. The thrust force go to the left. So acceleration need to be, what's the direction of acceleration? Direction of acceleration? Of course, follow the thrust force, isn't it? Follow the thrust force. You got F equal to ma. F equal to ma. The total force is on, let's say, only the thrust force. So the acceleration need to follow the thrust force. So the thrust force to the left, so acceleration also need to be left. A negative. This object will accelerate or decelerate? Last time you think that A negative means decelerate lah. Decelerate. So is this object decelerate? No. This object accelerate. This object accelerate. Now do you see why this is a misconception? A negative doesn't mean always decelerate. You must look at the velocity. You must always compare with velocity. If velocity is negative, then it becomes different already. Yeah, the situation becomes different already. So if velocity negative, A also negative in the same direction. You know, the thrust force same direction with velocity. So the acceleration also same direction with velocity. When acceleration and velocity same direction, this car accelerate to the left, become faster and faster. Become faster and faster. Now let's say about this. Let's talk about the last one, the last example. Now let's say about this car is moving to the left. Velocity negative. Okay. Now I no more pressing the oil. Now it's the friction. Now it's a friction only. The friction is to the right. So friction to the right. So the acceleration, the resultant force, the acceleration also follow the force. Acceleration to the right. So A is positive. So the object is moving to the left, but the velocity is to the left. Acceleration to the right. Yeah, opposite direction. This car will accelerate or decelerate. Yeah, the car is moving to the left, but because of friction, it will slow down. It will decelerate. The velocity will decrease. It will slow down until it becomes stop. Do you see that? Why it decelerate? Because the velocity and acceleration opposite direction. So this is what we call acceleration positive is accelerate, acceleration negative is decelerate. This is what we call it simpleton. You understand what is meant by simpleton? Too simple, simple-minded. The actual case is when make a conclusion from here. When the object will accelerate, you must always compare velocity and acceleration both. Don't just look at acceleration alone. And make judgment. No, we must compare acceleration with velocity. Okay, so when the object accelerates, conclusion from here is when velocity and acceleration same direction, both positive or both negative, the object accelerates. Okay, but if the velocity and acceleration one positive, one negative, okay, V positive, A negative, or V negative, A positive, when they are opposite direction, one positive and one negative, when velocity and acceleration opposite direction, the object decelerate. So I can make a conclusion out of from here. Yeah, the actual case is when velocity and acceleration both positive or both negative, same direction, the object accelerate. Object accelerate means velocity increase, become faster and faster. Now, when velocity and acceleration one positive, one negative, positive, negative, or negative, positive. When the velocity and acceleration, because opposite sign means they have opposite direction, then the object will decelerate. What is meant by decelerate? Velocity become slower and slower until it maybe it stops. Yeah, decelerate is velocity decrease. Okay, accelerate means velocity increase. Decelerate means velocity decrease. Okay, so when velocity and acceleration same direction, accelerate. When velocity and acceleration opposite direction, decelerate. That's all for this video. See you in the next video.